So cache replacement policy. The topics what we are going to discuss on here. You remember this topics is some factor there. Actually, this is very associate with the you can say virtual memory mapping concept. For time being, you just remember one thing that whatever the cache memory we have introduced, the concept of the cache memory and virtual memory has some significance. Cache was introduced for increasing the speed. Just remember these things. I think it is clear to you. Cache was introduced increasing the speed, whereas the virtual memory concept was introduced to increase the space. Okay, you should remember these two. One is introduced increase the speed, and one is introduced increase the speed. Just remember these two concepts. Very beginning. Okay. Now, our concept for compulsory misses generally pages that have never been paged into memory before. So automatically compulsory misses will happen, and most of the time you will find that in cold booting. I am also saying this is a cold booting process. Initially, when you start from very beginning, all the page reference will be not be there. So automatically you'll get the compulsory misses. How might we remove these misses? Prefetching, loading them into the memory before needed, or need to predict future somewhere more later. So it is very complicated process, need to predict. But prefetching generally, this prefetching algorithm should be followed in such a way that if the pages are required or not, you can fetch earlier. Basically, some basic input output system files for operating systems are loaded in the RAM, considering this prefetching concept to avoid the maybe just like in this way basic functionalities to open any process, the required file will be there in the memory. So this is the one option. But compulsory misses will not be so much significant thereby in course of time. That means when the computer is running and so many page reference will be executed, process starts executing, so automatically compulsory misses will decreases and becomes insignificant. The capacity means not enough memory must somehow increase the size. That is the architecture issues. Whenever you find that you are getting capacity misses for certain type of applications, then you only the option is that you have to increase the DRAM. So increase the amount of DRAM. We will either not quick fix because also some algorithm has some significant impact on some increase. Another option, if multiple processes in memory, adjust percentage of memory allocated to each one. Also, that is a very complicated task. Conflict misses, technically conflict misses don't exist in virtual memory due to the huge spaces. So anyhow you can allocate it. Since it is a fully associative cache, the conflict misses very less, but only conflict misses occurs mostly in direct mapping. And I also told that in direct mapping, I think there is no curiosity or there is no problem for that means any replacement policy. It cannot be used. So policy misses, I can say caused when pages are in memory but kicked out prematurely because the replacement policy. So that is our target. Who will solve these problems? I know the start. Why do you know replacement is an issue with any cache, particularly important with the pages? The cost of being wrong is high, must go. Since the cache is introduced, particularly for the solutions of getting the optimum speed for the computer, so replacement of the page has a significant role to get the increase. If the number of page fault occurs, you know automatically the miss penalty also consider also to be very high. So the algorithm is there, fast in, fast out. That means whenever you have a cache memory, you have a some suppose 4 pages are there. I have a 4 page A, B, C, D, 4 pages are there. Yes, suppose you have these 4 pages are there. Now you have to remove one page at a time. Either I can do randomly or either I have to have some error policy. So first one is the FIFO. That is throw out the oldest page. That means which comes first, you throw out. Let every page live in the memory for some same amount of time. This algorithm is bad because throws out heavily used pages instead of infrequently used pages. Sometimes it may happen. I will show that in the example that some pages you are replacing since it has come earlier, but it may be recurred. Suppose your page sequence is A, B, C, D, A, B, C, D. Disturbing today. A, B, C, D, and again you are trying to access A, B, C, D. What will happen when you are accessing first time A, B, C, D will come. When you are accessing A, it is already present, so there will be no changes. But suppose you are now accessing E, F, G, A or E, A, E, A, G, A, E, A, and 3 after G, B, A, like in this way. So what will happen? A, B, C, D, A will be replaced and E will take the place of this one. Now again whenever A is required, already again I will come, B will replace. So like in this way I will show that in the FIFO throws out heavily used pages instead of less frequency. So this is the drawbacks you will find. Minimum algorithm is the replace page that won't be used for the longest time. That won't be used for longest time. Again prediction. Great, but can readily know in future. Makes good comparison cases, however. So for comparison purpose, we will consider the random, again, randomly page for every replacement, typical solution for the translation loop buffers. So when we discuss the page replacements policies for virtual memory, you will find a TLB concept. TLB is a very important associate memory required for mapping the tag directives purpose. Pretty unpredictable, not suitable for use further. Okay. Now we will get the ALRU. This is our main desired algorithm. We would like to use the ALRU. Replace page that has not been used for the longest time. So can you tell me which locality of reference actually I am now utilizing here or exploiting here?
So, sir, repeat your question, sir.
My question is that by ALU policy, which replacement algorithm or locality of reference actually I am exploiting here? Replace page that has not been used for the longest time.
Sir, that spatial closest neighborhood.
What I am written?
Sir, I think it's temporal. Oh, yes.
Yes. I have written. What I have written is clear to visible to you?
Yes, sir. Yes, sir.
Yes, it's temporal because it is a mentioned already timestamp. It is not space related issue. The longest time not using. So actually it is a exploiting temporal. That means which is frequently used, just like a loop within the loop body. That will keep in the not will keep that. Which is frequently used, that I will keep. Which is not frequently used, remove it. Okay. So we programmer have locality. So if something not used for a while, unlikely to be used in the near future, so you can remove it. Seems like LRU should be good approximation to mean. Good approximation that in future I can approximate, but the past, from the past I can say at least some pages which are not frequently used, they are have a less chance to be used later. So you can release this. Okay. So in practice, people use the approximate LRU, some clock based concept, which is not in our syllabus, but even though I will discuss little bit examples. Suppose now with the algorithm I am applying. So suppose you have to, this is the algorithm A, B, these are page references. Use here you forget the 3 page frame, you consider these are 3 cache line. CH. I told that it is used in the virtual memory concept. Suppose this is the 3 cache line and these are 4 pages. Okay, 4 virtual pages and following sequences. Just forgot this point. Use this the page references using direct mapping. Is it possible or fully associative is possible? Using direct mapping is possible. This FIFO. Rajata.
Sir, it should be, sir, because we
It
are.
should be. I told that in direct mapping there is no placement replacement policy. Every time I am telling, are you people answering should be, maybe, not be.
Sir, I forgot that, sir. Missed out on that.
Forgot. I know. You know everything. I know what you are thinking. So you just remember in direct mapping, no prejudice privacy. How many times it is already fixed location, the page will be gone. There will be no rule or no right or nothing will be applicable. Only is applicable either shared associative or fully associative. Got my point? Where there is a chance if that particular location is not free, it will go automatically to the next consecutive locations. So that's why suppose you have some page reference ABC and the three cache lines are there. So I am using three cache lines. So this is my suppose cache line. Now initially compulsory misses for A because A is not found, so page fault occurs. So my red lines are indicate that is a page fault. So A is first in the cache. The second is the timestamp 1. Now second time you go for the second one. Okay. Now in second one again B is misses, so B page fault occurs like C. So A, B, C, three frame occurs. So automatically this in exam also you have to write like in this way. Got the point? So finally here will be A, here also A, here B and C. At the third clock cycle A, B, C fill up cache. Now again you are repeating A. So I think this A is present. This A is present or not? In my cache memory, what happened, students? Not
Sir, could you
responding the
repeat
class.
again, sir?
Huh? Are you getting my point or not?
No, sir. Could you repeat again, sir?
I am telling that pages first referencing. Initially the cache is empty. So first I am writing this is the cache. Okay. I will go to the Miro. Otherwise, this write the question first. A, B, C. You have written? You write the question. A, B, C, A, B, D, A, D, B, C, B. Written or not written? My page is there. A, B, C, A, B, D, A, D, B, C, B. Written, all of you?
Yes, sir.
Okay. Let's go to the Miro. Then I will show you how it is happening. Is it visible now, Miro? Now see, what is my cache size? 3 cache size I mentioned. Na? My cache size is 3. This is cache size. Initially all are empty. So first time when you are accessing A, automatically A will come here. So what is your problem? A, page reference B, C, A, B, C, A, B, D, A, D, B, C, B. Is it visible? Then A again page fault occurs for B. After the third locks, A, B, C are present. Is it clear? All of you up to this? 1, 2, 3 clock cycle. All these are present in the cache. Now you are accessing A. Already A is present. There is no fault. You are accessing B. Already B is present. There is no fault. Now you are accessing D and D is not their memory. So cache miss. So automatically one page will remove. Which page will remove? Which page? No. In LRUC, I can't say. There is FIFO. I am applying FIFO. Which policy? FIFO. Okay. Now since I am applying FIFO, which the come first? A. A come in clock cycle 1. So it will remove. So you will get D, B, C. Is it clear? Or not clear? Tell me.
Clear, sir.
Clear?
Yes,
Now
sir.
after that, now again you are accessing A. So here is D. Now B will remove. Then it will be like in this way. Again you are accessing D. Already D is present, no problem. But B is not there. Then it will be D, A. Then which one? B. Am I correct? Now you are again accessing C. Which will remove? Tell me now.
D, sir.
Am I
Sir,
correct?
D. Yes,
Okay.
yes, sir.
So 1, 2, 3, 4, 5, 6, 7. How many falls? 7 fall 7, or you can say 7 miss happen. Is it clear?
Yes, sir.
That's why the policy in a FIFO, but same policy also you can use for LRU. That time how initially A, this fault will occur, initial cases, then A, B, because policy will work when there is no space and also I am demanding something. Now up to this is clear. This part LRU and FIFO is same. Am I correct?
Sir, how are there seven faults, sir? Because we are replacing only four times, right?
1, 2, 3, 4, 5, 6, 7. Is it clear? 1, 2, 3, 4, 5, 6, 7. When I am drawing this thing, when there is a base fault. Otherwise, I am not drawing this block. Initial cases A is not there because it is a blank. Initial cases this. So A should be first. So A is miss. So A is first. Then when you are referencing B, B is not there in the cache. Is not there. Then again B should be first. So B have first and then fault. When C is coming, C still is not there in this memory. So again C have to fetch. So C is there. So that's why 3 fault happen initial cases. These are compulsory. First time access of the pages, compulsory misses. Getting the point? So this happens. Now after that, you are not accessing A. And that time you found here A is there. So there is no miss, nothing. That's why leave. Nay B already present. So again leave. So this also to leave. Then 4, 5, leave. Then you go for 6, 7. Now 8 also is not required. 9, 10. So total 10 access. I found 3 access. These 3 access, no misses occurs. So automatically 10 minus 3, 7. Clear? If you compute now miss ratio, that time it can be 7 by 10 miss ratio. And what will be the hit ratio? 0.3. Am I correct or wrong? This 3.3 times I got the pages. Clear or not clear? Tell me. Is it clear?
Yes, sir. Yes, sir.
Okay. So now what we are thinking that we have to change FIFO. Though how this sevenfold occurred is clear to you. So when referencing D, replacing A is a bad choice. That means I think you know that now I have to load D, but that time instead of A, if I there is a chance to delete D because A is used after that. So in FIFO that will not maintain. FIFO the first will be deleted, but in A, yeah, in case of LRU, what you can do, D will replace A and B just recently used, then C is almost not used, so D will replace the C. So that time D will come here instead of AB, and after that you will get A as a heat, D is a heat, B is a heat. So that's why we now in minimum algorithm same thing, same concept. Initially I told that this is the compulsory misses happen. This is the compulsory. Am I correct? This is the compulsory misses. It has happened. No problem. Now after that, A is a finding. B also it is available when you are accessing D. In min algorithm, which algorithm? In future, which has a less chance to be used. And I found that C, there is a less chance to be used after these 2 or 3 references. After that is coming, but in near future it is not using. So A is using, D is there, B is there. So after this step, I found it to replace the C. So A and B is there and replacing it is C. Here also A, B, C. Here also A, B, C. In the exam, you write all the every time the full the pages, so you can there will be no errors. Now D is coming. That's the color is differentiating. When D is there, next time is A is okay. Next time B is also okay. D also okay. No problem. Then whenever C will come, then A replace the C because I found that B's reference is there and D just is a also have some access maybe after if repeated the same situation. That's why C replaces the A, and it is continue after this because B is there. So like in this way, here page fault only 5 page fault. Is it clear? These three is compulsory. 3, then 1 4, then 1 5. Is it clear or not clear?
Sir, here we followed LIFO, right? Last in, first out.
Which will be accessed? There is a chance to access frequently. That means see what I have written. Replace pay that only be used for the longest time. That only be used in future. You are predicting actually. So a predictive logic should be there overhead. Are you getting my point? I found that there is a less chance to use C. That's why I replaced the C with D. I have predicted now. At least 2-3 references I have checked. I found A, so A is checking, and I found B also used, D also there. Okay, so here A, B, D, here A, B, D, A, B, D. So when D has arrived, I found that A is already there. B also will be used very recently, and D also after that. So only this, among these, only this is the parameter which cannot be used. Only this page is C, which has the less chance to be used in the next consecutive 2 or 3. At least you go the next 2 or 3. Okay.
Yes.
Okay. So
Then, excuse me, sir. Excuse me, sir.
yes,
Then how you replace A with C? I mean, there is
A
only B. We can also replace D.
after that when it is come as D just recently also, he after C it is predicted I have to replace either A or B because D has recently replaced with C. Okay, again C has come, C has to reply either A, B, D among any one of these. Any one of these, he predicted that B will be repeated. So that time either it can replace D or I replace A. Any one of these. Since D has
Okay,
recently
sir.
come just after A, so I have thought that D can be used later also. So mean is
Okay,
not
sir.
practically
Thank you.
available. Okay. Our main target is the ALRU. Now you check in the ALRU. That is my criteria LRU. LRU performs as same as FIFO here also. The total page number fault, this is common. This 3 fault is common. So A, B, here A, B, C. Now when D arrived, it is replacing A because A is not used last 2 consecutive cycle. So D replace A. So it looks like almost same as FIFO. It is in these cases, not all cases. Only in these cases, it is always almost same, but all the cases not. So it is found that every reference becomes a page fault. That time mean performs better. But I will show you some example here. ALRU. Suppose your page reference is like in this way. 70120304 like in this way, and number of page frame, instead of page frame you just number of lines. In these cases you consider number of lines 4. So initially for all are 0, empty. So first compulsory 7, then also compulsory 0, then also 1, that is also, and then also 2 and 2. So this up to portion for all I think common. Am I correct or wrong? These 4 misses will happen in every cases. Am I correct?
Yes,
Since
sir.
fully associative or set, maybe you can consider this within the particular set, or maybe it is a fully associative, whatever maybe. Okay, so in these cases, this compulsory misses happens. But if you consider two-way set, then that become difficult. Here for time being, we consider is a fully associative. Okay, so after that, when 0 has come, 0 is already present, here present, that's why it is a heat. So no need to write in the exam this column. I will understand it is heat. Got my point? Heat
Sir,
part,
in the
exam don't
first
write the heat part. In the exam, don't write the heat part. Clear?
sir, in the first 4 columns, why it is filled from the bottom, sir? Uh,
Not required. You can come top way also. It is just written. Okay. Top or bottom does not have any meanings. You can start 0, 1, 2, 3, like in this also. Okay.
But order should be followed, no, sir.
Okay, order 7012. 7012. After the 03 is order I followed here. What order you are telling?
Uh, Means I'm saying order should be followed, no, sir. Means we cannot go in disorder way.
Which order? Top to bottom you are telling?
Yes, sir. Yes.
So it is some reference from internet I've got. If you follow top to bottom, yes, every time top to bottom I will follow. If you go bottom up, then every time all these cases you will be scanning from bottom up. Is it clear?
Yes, sir. Yes.
That is not the main question. First, policy is clear or not, you should understand. In the exam, my question that no need to write heat, only the false you write. Is it clear? So this is was your question. Now, initially, I think in this part you have no doubts.
Yes, sir.
These four misses compulsory misses. Okay. Now after when zero you're invoking, zero is present, so heat. So no need to write. Then when three is coming, three is there. Three is not there. Then which will remove? Which list recently used? That means two is due, one is you have to go like in this way. And seven is the host which is not used. List recently. That's why I have to replace seven with three. Clear? 7 is replaced with 3. After that again 0, this is heat. When 4 has come, there is no 4. Then which one replace? You go again backward, you will find 3 is used recently, after 2, after 1. And then which one not used? Mostly 1 because 2 has recently again used. Are you getting my point? So 1 will be replaced with 4. Is this clear? Yes, or any doubt? Tell me first.
So what about 0?
0 is a me heat. Is a heat. So it's already present. So I can't replace it. Just now before 4, 0 has heat is so it is used.
Oh,
Least
okay,
recently
sir.
used. Recently I 3 also
Okay,
used. So 0 and 3 both are used. 2 also used recently. So which one not recently? 1. 1 is before 2 only.
1.
So only one will
Okay, sir. Thank you.
replace. Is it clear? So like in the 4 is replaced. When 2 will come, again heat, all are heat because all are references now present in the block. So number of misses 1, 2, 3, 4, 5, 6. That's why you found there 6 phase fault. Is it clear?
Yes, sir.
Now solve it. Solve the question. You have a 3 page frame, that means 3 case line. Size is like in this way. So initially this will happen. Am I correct or not? You just tell me.
Yes, sir.
I think initial cases this happen. Now you should think about it is gate question. Okay? Gate 2014 question number 65. My students should solve the question in the class. 7 is present or not? 7 is present?
Sir, but in the last question, sir, one question, sir.
First tell me this question, then I'll go again and return my last question. Don't compare with the knowledge. The knowledge should be clear. Tell
No,
me
sir.
your question.
That's what I'm asking, sir.
Where, sir? Sir, after 6, there will be 1, sir.
Sir, 6 will.
No, my question is that up to this is clearly understood or not?
Yes,
Prajota,
yes,
you have
yes.
some question. What is your question?
Yes, sir. Sir, in this question, we are loading the case from the top, sir, like 1, 2, 3, sir. But in the last question,
I told that from bottom and top up direction does not have any meaning.
okay, sir. Okay, sir.
You can start like in this way also. Get my point? Loading is up to you. Left hand and right hand batsman. Is there any difference in batsman criteria? Or left hand batsman gets advantage. They are twice they are getting out in the cricket match. Huh?
No, sir.
Prajota?
No, sir.
Then here it is not applicable. That means just like a batsman, left and right hand, whatever may be. Top down, bottom down, no problem. Is it clear? So I think 7 is a heat. Okay. 7 is a heat, so I will not count. 6 also heat, I will not count. Now
Sir,
1.
there is one
Sir,
also no sir
four,
before
seven,
7.
six, and one,
Yes,
sir.
sir. What is missing? Huh?
One is there no sir
Four,
before
seven,
7.
six, one.
So
Oh,
one
sorry,
will be
1
there.
is missing now. Okay, okay, sorry. So 1 I have to replace, na? Where I have to replace? Least recently. You
So
go 6, it is used. 7 also it used. 4 is not used. So 1 will go there. So it will be 167. Am I correct?
Yes, sir.
So after 7, 6 present. Now again 1 also present. Now 2. Which one will replaced?
So 7.
Yes. 162. Is it clear?
Yes, sir.
Now after that
Sir, 6 will be replaced as 7, sir.
172. Am I correct?
Yes, sir.
Then how many page fault? 1, 2, 3, 4, 5, 6. How many page fault?
So 6.
So what is the number of page fault? It should be 6. Very tough,
No, sir, easy.
no sir, no sir.
but कोई स्टूडेंट तो इसका नाम सुनते ही भागते हैं.
Sir, it's a little intimidating in the beginning, sir, but after that you understand, sir, it's easier.
अभी करो इसको. ये 2021 का क्वेश्चन है शायद, इस साल का नहीं, पिछले साल का, सॉरी. अभी थोड़ा दिमाग लगाना होगा. अभी तो तुम लोग मेच्योर भी हो चुके हो. दिमाग लगाओ. कुछ चीज देंगे, कुछ चीज नहीं देंगे. इन लास्ट क्वेश्चन दे हैव गिवन द ब्लॉक साइज, cache line size, so it's become very easy to find out. How many blocks are there in cache? 256 blocks.
256 blocks, sir.
256 blocks in the cache. Remember, 256 blocks. And consider a 2-year set as a 256 blocks. And user's LR replacement initially cache is empty. Conflict misses are those misses which occur due to contention of multiple blocks for the same cache set. There is a chance because direct mapping, and within the direct there is associative. Okay, so compulsory misses occur due to the first time access to the block. The following आप लोगों को compulsory और conflict बोल दिया है. आप लोग तो भूल जाएंगे ना एग्जाम के टाइम. So they have given the answer also. The following sequences of access memory blocks. 256 से हमेशा डिवाइड करके मुझे लाना होगा. मॉड्यूलर ऑपरेशन रिमाइंडर, इट विल सेट द व्हिच सेट विल गो. आपका पास 2 सेट्स है. कितना सेट है? सेट 0, सेट 1. ठीक है. सो 256 ब्लॉक्स, तो यहाँ पे हाफ वहां पे जाएंगे. ठीक है. और यहाँ पे हाफ आएंगे. एम आई करेक्ट रॉन्ग? नंबर ऑफ ब्लॉक्स 2 सेट. सो यहाँ पे कितना जाएंगे? 128 ब्लॉक. यहाँ पे 128 ब्लॉक रहेंगे. एम आई करेक्ट और रॉन्ग?
Sir, will the number of conflict misses be 76 total?
Total blocks is given 256.
No, sir, I'm telling the answer, sir. Total number of
Answer I am not do. I don't know. I have to solve it.
Okay.
My question, first page is 0. 0 modulo by 256. What will be answer?
So 0.
0, sir.
No, sir.
0. In which set it will go? In this set.
S0 sir.
0 set. After going 0 set, first free location occupied by him, no problem. Then 128 modulo 256. It will take 128 location. Okay. Am I correct or wrong?
Yes, sir. Yes.
So how will find out the which set it will go? Here 0
Sir,
to
S1.
127, yes, 122, 256, 255. Okay, so it will go here. Now again 256. So 256 remainder module 0, it will go at 0. 256. Is it clear?
Yes, sir.
Then 128 again here, again 0 here, 122, like in this way, repeated for 10 times. Now, when conflict misses, will explains the case.
Mm.
10 times it will repeated. So at least first time you do the all repetitions. First time you do. Is it clear? There will be 2 sets or number of sets will be huge. How many sets will be there? That is not clear to you, I think. Two-way set means what?
Sets, sir. So there will be 120 sets.
Yes, here will be 128 sets. Is it clear to you or not? I just written and all are following blindly. You people are Torchishman?
Sir, I am also a bit confused. I mean, how 120 is coming by 256 by 2?
See, two-way set. It means first you have to find out the number of sets. Number of sets you find out or not?
Yes, sir.
Then, what is the number of cache lines? How many cache lines are there? 256. Are you getting my point or not? How many cache lines are there?
256 cache lines. Since cache is given
256
256
cache lines. So that is the first thing. That's why I am solving, because most of the students did the same mistake what I have done. First of all, you have to, the logical formula is that I have to find out the sets. Here, 256 is the block. Blocks means the actual lines. No problem. Cache with blocks means cache always that deals with line. It is clear? So even I am writing cache with 256. So 256 lines are there divided by that set k way. Then you get the number of sets. How many sets are there? 120 sets are there. So in first S0, 0 set, I think 0 and 1. 0 and 1. And 27 sets are there. Are you getting? Are you getting or not getting? Tell me first.
Yes, sir. Yes, sir.
Yes, sir.
Now you do. 0 will take these places. 1 to 8. It will go in which places? How many sets are there? 120 sets are there. So 128 modulo 1 to 8.
0, 0, set 0.
There will be a conflict. Am I correct or wrong? Is there any conflict? See, they will go set 0, and inside the set 0, I think this is only occupied. This is free now, because two block per set.
Yes, sir. No conflict.
I can keep 1 to 8 here. Is it clear? Today
Yes,
is system also get disturbed little bit. Is it clear now? Okay. So it will be 1 to 8 here. No conflict happen. Now 256. Again 256 modulo 1 to 8. How much? I think 2.
So 0,
It will
sir.
2 or not?
Sir, modulo
So
0.
Modulo, sir.
yes.
Modulo 0.
Modulo is 0.
0.
Then again it will come here. Here now
Yes.
there is a
Conflict.
conflict. Am I clear?
Yes, sir.
And that conflict will be solved. Which one?
So 0 will be removed.
0.
So 0 will be removed, sir.
Because
0
our
will
policy
be
is
overridden.
LRU. Just now 1 to 8 has come. So 0 is there before that. Getting my point?
Yes, sir.
So here will be a miss will happen. So 256 and 128. Is it clear?
Yes, sir.
Okay. Then again you find out 128. It is there. There will be no problem. Okay. So two misses already happened for 0 and then 128. Okay. Now 128. No problem. After that again 0. Which will replace this one. Then you will get 256 by 0. See, all are dealing with the set 0 still now. Is it clear or not clear?
Excuse me, sir. Why 128 will be removed?
Because 256 recently has come. Recently 256 has come. After it is recently 256 has come. Sorry, 0 replace which one? 128. I'm clearing it. Just 1 minute. Just 1 minute. I have to clear it and then I'll tell you. This set 0, set 1. Like in this way, up to 128 sets. Now in this set, initially 0, then 128. কি ডিস্টার্ব করছে আজকে okay after that so no here 0 then 128 128 then 256 it will be 256128 now 0 this 3 has a already 3 faults now 128 is present. Okay, so yes, it will be 0 by 128. 256 will be wiped out. Is it clear for presence of 0? Now again 128, no problem. Again 256, it will be removed. Is it clear?
Yes, sir.
Okay. Then 256 hit, 128 hit, again 1 has come. 1 means 1 modulo 128. It will be wow, is same set or different set?
Set 1.
Set 1. So you write 1 here. So there will be a miss 256, 128 and 1 will become here. Okay. So again and then 129 I think same location. So 129 another miss will happen. Same set but in second block. Is it okay?
Yes, sir.
Is it okay or not? Yes. So 1 and there will be 129. Then 257 same thing. 1 will be replaced. Which one
One
replaced?
will be
One will
replaced, sir.
Yes,
Yes,
very
sir.
good. One will be replaced. Now do it and first out find out the number of total faults. What will happen in this way? Then multiply it with the 10 times. Then you will get the total number of faults. Is it clear?
Yes, sir.
So you have found a conflict as well as compulsory misses also. Is it clear? Tell me the answer next day. Did you write the questions? Can you tell me this question answer? The last question.
Sir, 76, sir.
How much is coming?
The 76, sir. The last question, right? The one with the 0, 128, that one, right?
76 coming, 10 times running.
Yes, sir.
You have to check it. Okay. Now, first time sequence, how many page fault has come? First time? Total phase false.
So actually in the first iteration there will be three compulsory misses, but
That
sorry,
will
six
not be
compulsory
happen
misses.
from.
Yes, sir.
That will not
In
be
the
happen
next
from.
iteration it will not
Yeah,
happen, sir.
yeah,
Yes. So
yes. That
sir,
first three
actually we have to
compulsory.
multiply it by 9 and add the number of conflict misses in the first one. So
Yeah,
it will come on
very good.
76.
Yes, very good.
Yes, sir.
That means directly just repeating the 10 multiplication will give you wrong result
Yes, sir.
because
Yes, sir.
after 10, after first iteration, you see what is the cache content present there. Okay.
Yes, sir.
So tomorrow, anyone I will check. Tomorrow on the day after tomorrow, whatever maybe after Wednesday and Friday, Dr. Mousumi Shaha will take the classes regarding your RAM-ROM design, and these sections I will again repeat after her class. Okay, so you will get ample time to prepare on these topics, and this slide I will also upload today. Clear? Am I correct?
Sir, I have a doubt in the last question, sir.
What doubt? Tell me.
Sir, when we are using 256 for the first time, so that
Yes.
should be compulsory misses. Conflict misses are those which we have first put
I
in the
know
cache.
this is a compulsory, but that time you have to occupy some spaces.
Yes, sir.
So both happen. Compulsory conflict together happen.
So
So
means
from
counting total misses, we have to include the
Or,
compulsory misses also.
or just page false, just frame false. Whenever you are doing for compulsory or conflict, whatever may be, it is a fault. Okay. So
okay,
fast
sir.
access of 256 automatically lead is compulsory and conflict. Did they ask only count compulsory or conflict? I know. Check the question.
Only
What they ask?
conflict.
Oh, sorry. The number of conflict misses only I have asked. So ignore the
Sir.
complex. Yeah. Sorry, I have not checked it. So yeah, you can do it since they asked about the number of conflict misses only. Number of conflict misses. So yes, then don't count the compulsory one. In initial cases, 256 will come. It's also compulsory, but also when you are going to load, that time it is giving conflict or not. Am I correct or wrong? Whenever first time 256 is coming to you, 256 is a compulsory, I know fast access, but also it leads to the conflict or not, because his position is occupied by 0 or 128. Am I
Yes,
correct?
sir.
Then in these cases also you have to consider conflict cases. Clear?
Yes, sir.
Can you tell me that this answer is very small question? The last question for this today, GATE 2007 question.
Which friends?
See, the topics whatever discussed, everything in the classes. So I think there will be no fear factor for GATE exam. You are solving in the classes, so you should be confident.
Sir, I'm solving it, sir.
Is answer
Sir, 7
7? Okay, very good. Answer is 7. 7. Who
Sir,
has
it's
solved
7.
7? Another, please check. Answer is 7.
7, sir. It's 7, sir.
Yeah, cross check it. Should not be 9 because optimal page replacement policy. Have an idea of the future which will be there is a chance to used. Did you get my point?
Yes, sir.
Not least recently, when you are first time you are doing that time it is 1 to 1, then 1 2, then 1. I think note required 1 to 1, then 1 2, 1 2 3. So these are the compulsory misses. Now when 7 is arriving, which will replace? I found that which is the chance to use. 3 and 1 has a chance to use. So I replace the 2 only. So near future this reduction will be less. So optimal page probability thinks about the future references of the spaces, pages. Is it clear?
Yes, sir.
So it is optimal. He has the prediction features that in future which can be used and the which has the less used chance to use less, that will be replaced. Clear? Okay. So today I am keeping this concept up to here. After that I will go Ballard's anomaly. You just giving the remember, sir, Ballard's anomaly. Okay. You just give me a reminder, sir, you discuss Ballard's anomaly. Okay.
Okay, sir.
You give me that, sir, you have to start from Ballard's anomaly.
Okay, sir.
I just am giving the idea. It is found after discussion that whenever number of frames you are increasing, the page fault occur. Generally, it is a chance true fact. Am I correct or wrong? I found that instead of 3, if I use 4 blocks, automatically huge number of pages I can occupy in fully associative or set associative. Is a true fact. So it happened that whenever the number of page fault decreases, whenever you increase the page, but in FIFO algorithm, it is not always true. You increase the page size, even the more fault will occur. That is Ballard's anomaly. Is it clear? And Ballard's anomaly occurs only in case of FIFO algorithm, not in LRU. Just remember this point. That's why I told that certain replacement algorithm FIFO does not have this obvious property. Is it clear? Here initially 3 pages and this page reference considered, they found the total false. Again they increase the page size. Instead of 3 they consider 4. Now frame size increases, even the fault more. So that's why it is always true, I can't say. Am I clear? In case of FIFO, this happens. So Ballard's and FIFO algorithm suffers from Ballard's anomaly sometimes for page references. That's why I mentioned not necessarily for FIFO. Is it clear? Though I have even covered, in next class I will discuss this point again. Okay.
Sir, can I have the answer of the last question I missed, sir?
This one.
So last question.
This one. You
No, sir,
solve
not
it
this
and
one. The question after this.
is this one.
The question after this, last question, sir.
Last question I asked this one, na?
Answer is A. Okay, sir. So, I got it.
Okay.